So here we are at the second quiz. We've put in Miller and best guess, and now we're talking about Betty instead of Bob. This is completely different phenomena. This is a velocity graph, not a position graph. So we have to realize that these numbers here on the y-axis are not where Betty is, but instead how fast and in what direction Betty's moving. So here at the very beginning, Betty's not moving at all at the very start because her velocity is 0. And then she speeds up, and as we move away here from the x-axis, the further away we are, the faster that Betty's going. So going in a positive direction this whole time. For the first 6 seconds, Betty's moving in a positive direction. And so here she is moving faster and faster and faster till at 3 seconds, she's still going forwards, but now she doesn't quite go as fast anymore. But she still moves forward and moves forward and moves forward all the way until 6 seconds. Her speed is given by this graph, but realize that this graph is velocity. So the velocity is positive up here, and velocity is negative down here. So let's look at the first questions. Number 1, what is Betty's velocity at 10 seconds? Well, at 10 seconds, we're down here at negative 9 meters per second. So we can say with confidence here that her velocity is negative 9 meters per second. What is her speed? Speed is irrespective of direction. So instead of saying negative 9 meters per second, we're just going to say 9 meters per second. Where does Betty turn around? Well, we were just talking about how when the value for velocity is positive, she's moving forward. So she's moving forward from 0 seconds all the way to 6 seconds because these velocities are positive. Here the velocities are negative when she's going from 6 seconds all the way to 12 seconds. So she has to turn around when her velocity goes to 0. So that's going to happen at 6 seconds. When is Betty standing still? Well, not very often. Okay, she's technically standing still at the very beginning. Then she's moving faster, 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 faster. Then she slows down, slows down, slows down, slows down. At 6, she's standing still just for a moment. Then she speeds up again, going negative directions, and then is going very fast for this whole time from 9 to 12 seconds, going negative 9 meters per second, which is very quick. So she's only standing still at 0 at 6, and 0 is not on here, so we'll go for the 6-second answer. This graph is a velocity, remember? So the next question about how far she moves from 0 to 6 seconds is not so easy because this is a velocity curve. So to get to the position or the change in position, we're going to need to look at area. So I think I'll copy this image over again here so that we can work a little easier. And let's look at what is the area under the curve, because the area under the curve here is going to be the position. And since we notice that we have a triangle and the base here is 6 seconds, and we see that the height of the triangle is given by 9 meters per second, then we can get that area by simply saying that area, which is base times height, and we need the half because it's a triangle, is simply 1/2 6 times 9. And so if we take half as 6, that's 3, and 3 times 9 is obviously 27 meters. So we're saying that this 27 meters here is the area. Here is our change in position. And it's in a positive direction because all of these are positive values here, since our velocity is positive from the origin going this way, and our velocity is negative if we're going down this direction. So she moves a positive 27 meters here. So let's go back to the quiz here and take a look at what that answer is going to be then. So how far did Betty move from 0 to 6 seconds? So that's clearly the area under that first, this triangle here. So it looks like we've got 27 meters. Number 6. Assuming Betty started at P equals 0, then where is she at T equals 9? So T equals 9. I'm going to come back to here. At T equals 9, we're here. And if we look down, that's at this location. So to figure that out, we'll need to figure out this area here in the negative region. But that's half of one of these earlier triangles. So I think that we can just take half of 27, and that gets us 13.5 meters. Okay, and we're going to think of this as a negative number. And so this means that she came back halfway because she went 27 meters forwards, but then turned around and came negative 13.5 back. So she still has positive position, but it's at 13.5 meters. What is Betty's acceleration at t equals 4 seconds? So acceleration is the slope of the velocity. So what we want to do is think about what is this slope here. Let me grab, say, a different color. So we'll say the slope here, which we did the math earlier on the position graph, but we can see that we have a 9 over 3 because this is 9 meters per second over 3 seconds. So we get acceleration of 3 meters per second every second. Okay, and that's a positive value during this. And then we have a negative 3 meters per second during this whole time, because that's the slope there. And hopefully now we can answer the questions. Let's take a look. So what is her acceleration at 4 seconds? 4 seconds is on her way back down during this region right here. And so that's going to be the negative 3 meters per second. When does Betty pass back through her original location? Well, we've already figured out that at 9 she hasn't come back yet, because if we look back here, and maybe I'll make another graph here, we know that in this zone right here she went 27 meters. We know up till 9 seconds that she had traveled 13.5 negative. Okay, so we have negative 13.5 meters. So she needs another 13.5 meters coming back. And that's going to happen at 10.5, because this area here, this rectangle, is going to give us another negative 13.5 meters. Okay, and you can figure that out because this is 1.5 seconds when we go from 9 seconds over to 10.5 seconds. And since her velocity down here is negative 9 meters per second, the 1.5 times the negative 9 is going to give us that negative 13.5 that we need. So we get a total, if we take all of this zone here, we get a total of a negative 27, which is what we needed, because over here we had a positive 27. So she's back to the origin again when she gets at 10.5. So there we go, 10.5. That was a tough question. When is Betty going backwards? So she's going backwards whenever her velocity is negative. So that's going to happen from 6 seconds over to 12 seconds, which is that first one. And then how far did Betty travel during the full 12 seconds? Now this is total distance traveled. So we know that she went 27 in the first one, and she went another 27 to get to 10.5. So we're looking at a number that's bigger than 54, because 27 and 27 is 54. So it looks like 67.5 would be a good guess. If we're going to check that, we might want to think about, well, what's this area that's left in this zone, right? And it looks like we have another 13.5 meters here. So she went 27 total here. She went another 27 total here up to 10.5 coming back. And then she did another 13.5 here. And we get those just by thinking about those areas and adding up all those different areas. So 27, 27, and 13.5. I should get a 67.5. We'll submit that and see if I made a mistake or not. Let's take a look. And looks like I didn't mess up this time, so that's handy. There we go. Hope it helped.